Okay, so there's going to be four sections in this, four lessons in this chapter. Um, it's probably in some ways like quite a bit different than what you might think if you looked in the book. Two of those days are probably going to be heavily using the calculator to do things that we might have been doing a little bit along the way, but I can't assign homework for you guys to take it home. So I'm kind of like concentrating it a little bit in this chapter. They are kind of calculator procedures that you're supposed to know. And most of what we do today will be that. And because I can't send you home with a calculator, I mean, what you're going to get out of this is going to be what you get in class right here. There will be something that's a little different right at the beginning, which is, you know, what do we mean by a polynomial? We need to know that kind of thing before we start doing the rest of it. But mostly what we're doing is we're learning how we can model data with mathematical equations using the calculator, right? You don't have to do it by hand. You just have to know a few steps in the calculator, and you can actually have the calculator do all of it for you. Right? So that's mostly what we're going to be doing today, is looking at that. But like I say, first we're going to get into, you know, what's a polynomial and some of the basics about that. So polynomials, the word polynomial means many terms. Poly for many, the nomial part is for terms. Now, what do we mean by terms? Right? Terms, whether it's in an expression or an equation or a function, terms are separated by pluses for addition, minuses for subtraction. So, for example, in this expression right here, there's two terms. Right? Two terms. In this equation on the left-hand side, there's three terms. Right? That's how you count terms. Right? Do I have my pen on? I don't have my pen on. It's not more than one term. If I say something like 2x squared, right? That's not two terms. That's not like 2 and an x squared because they're not separated with a plus or a minus. Right? It's only when they're separated with a plus or a minus. And by minus, I mean not a negative sign, but a subtraction. So the first thing that we do in this chapter is just, you know, figure out how is it that we talk about polynomials. We talk about polynomials by referencing two characteristics. One of them is the degree, and one of them is the number of terms. Okay, in terms, number of terms, when you have two terms, you actually call that a binomial. Bi, like bicycle, right? Binomial means two terms. Right, so this is a binomial. Right. When you have three terms, what do you think you'd call that? It's a trinomial. And we've actually already done that, right? In the last chapter, we were doing the perfect square trinomials and simple quadratic trinomials. So this is three terms. And actually, a monomial means one term, mono for one. So this 2x squared could have actually been a monomial. But when you get above three terms, like the function over here, you just say polynomial. Right? They're all polynomials. Every one of these is a polynomial. Right? But when it gets above three, you say polynomial. If you're asked to classify by number of terms, you need to say monomial for one, binomial for two, trinomial for three, and then above it say polynomial. Don't just say polynomial for all of them, even though it is kind of technically true. Right? So this is polynomial. Right, so 4 plus terms. The second way, so this is number of terms. And the second way you refer to a polynomial is by the highest power of x. And the highest power is called the degree of a function. Like in this one, we actually already know this, right? X squared plus 1, the highest power is 2. What do we call something that has a squared term in it? Quadratic. It was the last chapter, right? Quadratic. Okay, now newer words for us would be, when it's a x to the third, that's called cubic, right? Cubic. Right, that thing right there is what's telling us that it's cubic. I'll do this too. Okay, and the fourth is quartic. Now, one that's not listed there is linear. And linear we've dealt with before. Linear means it's x is to the first power. If the highest power of x is to the first power, that's linear. Something like x plus 5. Right, and that's linear because it's x to the first. So if somebody says a quartic polynomial, you know that it has an x to the fourth as the highest power, and it's got at least 4 terms. So there's a table in the book that kind of puts all this together. And if you could see it, if you can't see it too well, then look in your book, right? Section 5.5-1. But it gives us, like, if you're using names to degree to say the degree, you could say a constant function means like just a number, right? 5 is a constant. There is no variable. That's the degree of that is 0, because what is anything raised to the 0 power? It's 1. Anything raised to the 0 power is 1. So x to the 0 is 1, which is why you don't write it. That's why you don't see an x in there. But there could be an x. That's what it's, the degree is 0. Linear means degree is 1. Quadratic means degree is 2. Cubic means degree is 3. Quartic is 4. Quintic, as you might figure out, is 5. The last two especially, I mean, those are kind of odd words. You probably need to recognize quartic for something that comes up a little bit later in this lesson. But if you said 4th degree, that's not wrong either, just to say whatever is that degree. We should know the more common ones. Quadratic, cubic, all the time. Quartic and quintic a little less. What do you see down here? What if it was x to the 10th? You're just going to say 10th degree. Just say the number, right? Here's their examples. And then by number of terms, again, this first one, there was only 1 term, so it was a monomial. The second one, there was 2 terms, so it was binomial. The third one was another monomial, 4x squared. The next one had 1, 2, 3 terms. That made it a trinomial. Right? 2x to the fourth plus 5x squared, binomial. And then here's the one, because it has at least 4 terms, 1, 2, 3, 4, polynomial. Now, one thing, if you notice the writing of these examples right here, in every case, the highest power term is all the way on the left. And then if you look at the next term over, it's always a lesser degree or lesser power. So x is the highest degree term, and then a constant of 4. 4x to the third, the next term is squared. The next term is to the first power. Right? Here's the x to the fourth, and then the next term is a squared. So it always starts with the highest power term to the left and then goes down from there. That's called standard form. They're always written in standard form. When it's written in standard form, you could tell the degree just by looking at the term on the left. You don't need to look at the whole thing. You just look at the term on the left because that's the highest power. So the only problems you're going to get in the homework are going to be problems like this. Right? Because we can't, the rest of what we do, you need the calculator for, and you're not going to have the calculator to do this. When it's going to give you a polynomial, but it won't be in the standard form, right? If it's like this one here, how would you rewrite that to be in the standard form? What would be the first term on the left? The 9x squared, and then the 3x, and then the 5, right? But if it's like this one here, what you notice, and this is going to be the thing you got to look for, is there might be some like terms that have to be combined. Like, which are the like terms that you see in this expression here? Yeah, these two right here are like terms. So they need to be combined. Before you write everything in an order, combine the like terms, right? So those are going to be by themselves, that's 4x squared, right? We did a little bit of this at the very beginning of chapter 1, right? How do you combine like terms? Like terms are same variable raised to the same power. You add the coefficients. Negative 6 plus 10, 4x squared. Okay, once we've done that, what is going to be the first term on the left of that polynomial? The x to the fourth, right? The highest power term will be x to the fourth. The next will be the 4x squared. The next will be the 4x, and the last term would be negative 12. Right, so here, this one is rearranged. There's our standard form. Here's our standard form. Okay, next part. Classify by degree and number of terms. Right? By degree, this letter A, what would you say? It's quadratic, right? By degree, it's quadratic, and by number of terms, it's 1, 2, 3, trinomial. Quadratic trinomial. How about this one? By degree, it's quartic, and by number of terms, it's Deshaun? It's a polynomial. It's got 4 terms, at least 4 terms, so you could just, so this is a quadratic trinomial. This one is a quartic polynomial. So let's try these here. Put them both in standard form and then classify by degree and number of terms. How is this one rewritten in standard form? Say again? Right, the first term is positive 5x to the fourth. Oops, that's wrong. 5x to the fourth plus 3x to the third minus x. Right, how is this one rewritten in standard form? Negative 4x to the fifth. Next, 2x squared. Next. Can you? Yeah, you can, and you have to. Plus 13. Okay, so both of those, when you classify by number of terms, what are you going to say? 3 terms is trinomial, right? Trinomial. trinomial. Right? By degree, what are you going to call this one? Quartic. And how about the second one? We already said that's a trinomial. By degree, it is to the fifth power, quintic. Okay. So that the homework problems are just like that. Right? They're just a bunch to do this exact same thing. Combine like terms, put them in order, classify by degree and number of terms. That's it. Right. The rest of what we're going to do today is going to be using the calculator to do some things that are, like I said, most of those objectives that we had at the beginning, those all coming from the SOLs. It's really kind of the focus of all of Algebra 2. It's supposed to be to expose you to a lot of different kinds of functions and then pick appropriate functions to model data. Because you may not be a mathematician in your life, whatever your career is, but you probably work in some kind of business that you're collecting information. Information is just data. And somebody's going to try to make sense of it. And how do you make sense of it? You try to see, does it represent any kind of pattern that I recognize? And the first pattern that we look at is linear. Right? Linear is the number one kind of pattern we look for in data. Now, this one in particular, before we start looking at scatter plots of data, remember that in Chapter 2, we were supposed to be able to come up with the equation of a line if we had 2 points. And if you remember, we did that by doing this. We used point slope form. And because we didn't have the slope, the first thing we did was calculate the slope, right? So the m of this one will be 8 minus 2 divided by 5 minus 3, which is 6 over 2, 3. Right? And then we took that, we replaced the m in this equation with 3, and we replaced the x1, y1 with one of these 2 points, and it didn't matter. I think I'll pick the lower numbers, right? So it would be y minus 2 equals 3 times x minus 3. Solve for y, right? Distributive property, y minus 2 equals 3x minus 9. Add 2. Do I have this right? 2, yes, okay. Y equals 3x minus 7. Right, that's what you're supposed to have learned in Chapter 2. In fact, your calculator will do that all for you. With a very easy set of procedures, you can get the calculator to do that for you. So that's what we want to do next. Like, you're not going to get asked to do this in this chapter, right? And after you know what I just taught you, you may never do this again. If you got a calculator in your hand, you're just going to do what I show you to do in the calculator. Okay, so here's how we would do this. Same thing in the calculator. So if you got your calculator out, and I would, just to make sure we're all on the same page, let's clear memory first. Do you remember how to clear memory? You hit second, plus sign, and you should see a menu that looks like this, and you go 7, 1, 2. 7, 1, 2 for reset, so we don't have anything else, you know, you're coming up with I's and we're not coming up with I, things like that. We don't have to worry about that. Okay, so first step, you got to enter those points in the calculator, right? Where do you do that? Stat, right? There's the stat button right here. See that? Hit stat. And what do you see along the top? Edit, calc, and test. Okay, we want edit. Stat, edit, which means you can just hit return because it's already on edit. Hit return. And what you see is lists. L1 is list 1, L2 is list 2, L3 it goes on a little bit. If it doesn't say L1, L2, L3, then we need to fix your calculator. Sometimes kids delete L1 and then it starts with L2. That might be a little bit of a problem. Okay. All right, now we're going to enter the X values under L1 and the Y values under L2. Right. So our X values are 3 and 5. And you have to hit enter after every number that you put in. So we're going to say 3, enter, 5, enter. You then arrow over to the L2 column to put your Y's. 2, enter, 8, enter. Right. So it should look like I can put parentheses around those. Those are my points. 3, 2, 5, 8. Is everybody at the same place? We're good with that. Okay. Second step. Where's my calculator? Okay, now you go. Stat calc. Remember when you hit the stat button, there was actually the middle column said calc. So arrow over to calc. And now when you look at that menu there, the fourth option says LINREG, which stands for linear regression. That's the one you want. So you're going stat calc 4. And it should give you something like that. It says linreg ax plus b, hit enter. And you should see a screen. Now, first of all, let me go back a step. Okay. When you go to stat calc 4, right, you don't see what I saw there, right? You see this. You see this. My emulator up here doesn't have the screen you have. That's I copied this from my actual calculator, right? So you have to go down the list. You could just hit enter, 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 enter until you get onto the calculate, or you could arrow down until you're onto the calculate, and then hit enter from there. Eventually, you're going to get, it's going to say that on the screen, and you hit enter. And now, this screen is this screen here. So y equals ax plus b. The a is 3, and the b is -7. So it's like saying mx plus b, which is what we recognize as a straight line. The calculator says ax plus b. Pretty close to the same thing. So if you get to this point, you're not quite done. You need to write the equation with the a and the b substituted. So y equals 3x minus 7. Right? That's the same equation that we got on the last slide, going through that process of calculating slope and putting it into point slope. In fact, your calculator will do that for you. So if you have your calculator in your hand and you're asked to do that kind of problem, by all means, use your calculator. Right? What if you were given a question like, here's 2 points, calculate the slope? Do the same thing, right? The a is the slope. Whatever that is, that's the slope. They didn't ask for the whole line, they just asked for the m part of it, which is a. Pretty easy? Okay. Then try this one. Try to do the same thing for those 2 points. Come up with your equation of a line for the points 7, 11, and 13, 17. Jose, let's go. Right? Use those 2 points. Stat, edit. Stat, edit. This is going to be your practice of doing this. Did you get it? Stat, setup editor. Okay, stat, edit. Make sure, well, who's got an answer? Yes. Did you get it? Where's your calculator? Go get it. Right? If you won't even try, believe me, I am not helping. Okay? So remember, right? Y equals, right? It's a line. Yes. You get it? Okay, remember, you got to write it down there. Write down the equation. You getting it? Did you put the data in?
Turning to the window point.
Stat. Enter. Okay. Yeah, Sam. Yes. 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 Did you get it? Okay, write it down then. Good. So what was the answer? Right? So remember, you should write it out, right? You should say y equals 1x plus 4, and even better, which a few of you did, is you say y equals x plus 4. Because we usually don't write a leading coefficient of 1, right? For a coefficient of 1, you just assume anyways. X plus 4, that's it. So given 2 points, which, remember, a line contains infinitely many points, but you only need 2 points to define a line, right? In fact, if all you know is 2 points, there's only one line that can go through those 2 points. Okay. Good question is, what do you do if you got more than 2 points? Okay, like in this picture right here, I've got 3 points. Does it look like they're all on the same line? No, they're clearly not all on the same line. So when you get that kind of situation, we still try to draw a line through them, right? But why is that doing that? Oh, that's funny. It's grabbing the wrong thing. You know, it's still trying to draw a line through it, but you know exactly where does that line go? You know, it's somewhat of an approximation. You try to make it the best line you can that goes through what looks like the middle of the data, right? Okay, that line, when we come up with it, is called the line of best fit. You're going to see those words, best fit. The book also calls this a trend line. They don't call it, at this point, I don't see that they're calling it a regression line, but that is what it is. I mean, when you hit that stat calc 4, what did it say? It said lin reg. The reg is for regression, right? That's where the word comes up. So linear regression would be the name of the best fit line. The way the calculator is going to calculate our best fit line is you can see where the line goes. It's, in this case, that line is not hitting any point. It's somewhat in the middle. So it's missing this point by being a little bit too high. It's missing this point by being a little too low. It's missing this point by being a little too high again. The calculator calculates those differences and tries to minimize the errors that you're looking at. So it's trying to draw it right in the middle so that the error between the line and the actual points are minimized. That's how you come up with the best fit line. Now, how are we going to deal with it? The same way we just did. There's no change to our procedures if we have more than 2 points. Just put in all your points. Just understand, because there's more than 1 point, this is the best fit line, not necessarily the only line that goes through those points. Right? So let's try to do the same thing with this one. I'm going to go ahead and do it here. Right. Stat, remember, what do we do first? We go stat, edit, or enter, and then under the L1, let's put all our X values, 0, 2, 3, 7, 8. 0, 2, 3, 7, 8. Arrow over. When you arrow over, notice that it's not putting it all the way at the top. You need it at the top because there's numbers in there already. Then just arrow up. Make sure you're putting it in the right spot. 11, enter. 8, enter. 7, enter. 2, and 0. Okay, so those should look like your points. We had 5 points. Should look like just those points. Okay. Next step. Stat, calc, for, calculate. Stat, calc, for, And for yours, go down to the calculate. Just keep hitting enter until you get down to the bottom, and then you hit calculate. Let's see what's on the next slide. Right, that's what I got when I did that. So I would write it as y equals negative, and you're going to have to round off a little bit, negative 1.33x plus 10.9. Something like that. Yeah. Error archived. Okay, stat 01128377280. Those look good. Stat calc 4. Taken from L1 and L2. Go to. Let's clear all that. Try it again. Stat calc 4. So, clear in memory. I don't know what happened. Second plus 7. Try it again. That'll usually clear it up. You don't want to write down all those digits there. I did 2 decimal places there. I could have done a 10.90, but the same thing as 10.9. Okay, so this now is not the only line that goes through those points. It's just the best line. It minimizes all the errors. Yeah. Really? Another calculator. I don't know what's going on. I do not know what's going on. Limreg archived. Okay, try to do the same thing. I think I got one more loaded like this. Try to do the same thing for those 5 points. Come up with your regression line, the best fit, the trend line that goes through all of those. Most of this stuff is coming from Chapter 2, because there was a section for us to do this in Chapter 2. All right, but I just thought, well, I'm not going to do it in Chapter 2 and Chapter 4 and Chapter 5, because you can't take a calculator home. We'll just wait till we get to Chapter 5 and do it once. In fact, later we have to do it for exponentials and logarithms. Is it working now? I wonder what's going on with this calculator. Oh. So I don't know what you guys are doing here, but stat 5, enter. Negative 10, negative 5, negative 1, 3, 12. 3, 1, negative 4. Negative 7, negative 12. That was wrong. Negative 12. Stat calc 4. Right. You should have gotten that. Compare that on your screen. It works now. If you get errors one thing to notice, when you do the stat edit, if you don't have L1 and L2 there, then you got to get L1 and L2 there. Or, I mean, notice this. When you go stat edit, no, stat calc 4, right? It tells you where it's drawing the data from. It says it's taken, the X's are coming from L1 and the Y's are coming from L2. You can change that. If you put the data in L2 and L3, you just change it to say L2 and L3. But most of the time we don't, we just assume that it's in the L1 and L2. That's why it was given errors. Okay. So this is linear. Okay, now, if you go back to that menu, stat, calc, and what you're going to see is, actually linear was just one of the options you had, right? We don't have to pick linear every time. You could have picked 5 as quadratic. We know what a quadratic is. 6 is cubic, right? At least we know what the name cubic now means. It means it's got an x to the third, right? Quartic is the 7, the option 7 on there, right? Which means it's got an x to the fourth in it. So you would, if you were going to approximate data with a model, then you're still going to enter the data exactly the same way. Then you're going to go stat calc, and then you're going to pick which one of these you want to use. Well, how are you going to decide which one you're going to use? You're going to have to look at the data and just see what does it look like. Does it look like it's a straight line? If it looks like it's a straight line, use linear. If it looks like it's a parabola, use parabola, right? Use the shape that's most like the data that you're trying to approximate. The first 3, we don't mess with. Not here. We will at the end of class when we get to the statistics stuff. Mean and standard deviations and things like that. We use them 1. 2, we won't use these 2 here. In fact, if you go to the calculator, stat, calc, there's actually more down below there. If you go down below, you'll see the 8 is another version of linear. 9 is a logarithm. 10 is an exponential. 11 is power. 12 is, that's A, and B is, they call logistics. The next one is a trigonometry. So we have a lot of different options to model data based on what we're looking at. Right, these are the shapes that we're going to keep it to. We're not going to go any higher than 4th degree quartic. Right, we already know what we mean by linear. Right, linear means it's a straight line. Right, this would be the example where the m is greater than 0, the slope is positive, so it goes up. This would be the example where the m is less than 0. Right, for a quadratic, we know the shape of a parabola. A parabola is like a U, right? And we knew when we did the parabola that if the leading coefficient, the A, was positive, then the parabola opened up. And if it was negative, it opened down. But in any case, it looks like a U. Right? Cubic has either one of these 2 shapes, right? Like that or like that. Again, the same difference, right? If the leading number, the leading coefficient is positive, then you expect it to have this shape. If the leading coefficient is negative, you expect it to have this shape. And then quartic, 2 versions of that too. What we're supposed to notice in general about polynomials is for every degree more that you go, you get 1 more change of direction in the graph. Like a linear has no changes of direction. A quadratic has 1 change of direction. A cubic has 2 changes of direction. A quartic has 3 changes of direction. How many changes of direction would we expect a quintic to have? 4, right? It's 1 less than the degree, right? 1 less than the degree, that's how many turning points that you find on the graph, or could find. You could have less, but you can't have more. Right? So right now, we just had to know these basic shapes, right? And we already know the first two, should know the first two pretty well. Okay, so how to view a scatter plot. Now, if you still have the same data in your calculator, which I hope you do, the last set of 5, just leave it like that, like it is, right? This is how you look at data in the calculator. First, you enter the data, which you've already done if you've got those points in there. The second step, if you notice on your calculator, right, above the y equals, it says stat plot, right? Stat plot. So you have to go second, y equals. Right. Now, if you hit 1, right, it's already highlighted on 1, but if I hit 1, then you can see that if you want to plot points, you've got to turn it on. It should be automatically, by default, it's turned off. So now I've got it blinking on the on, so I hit enter, so that it's now blinking, it's actually highlighted on the on all the time. So we just turned on the plotting of points. Now, once you've turned it on, you don't need to turn it on again. It'll stay on until you like reset your memory or something like that. And then the last is you would like it to make the window around the points you just put in, right? If I go zoom 6 or just the normal zoom, then okay, in this case you can see your data, but sometimes your data is nowhere near the middle of the graph. So if you wanted to go to just the points you put in, you go zoom stat, which is zoom 9, right? So we just hit zoom, and you don't have to scroll down, just hit 9. Zoom 9, and you should see your points. And your points should look like this. So zoom 9 brings the graph to those points that you just put in the calculator. Yes. Do you have the points in that we just did on the last one? Where's your stat edit? 10, 3. Okay, zoom 9. Zoom 9. So those aren't the exact points. And it could be that one is a little bit off, like a minus sign is wrong or something like that, or maybe they're not the same data. But as long as you know the procedures for getting there, right? If you have the same data we did on that last one I asked you to do, it would look like that. If you don't, then it's not going to look exactly like that. But you should know, how do I look at data? Turn on the plotting of points, zoom 9. And now, if I zoomed 9 on this data and I looked at it and I tried to compare this shape to these shapes, I would have said it's linear. So that would have told me, okay, use the linear regression, stat calc 4. Right? If it looked like a U, I would have done stat calc 5 for quadratic. Okay, so try to do that on this. Put these 4 points in the calculator, and then look at the plot and see what you see. Yes. Uh-huh. Mm-hmm. What you got? Uh-huh. Okay. 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 Bye. Sam, you need to go to the dean. Go to the dean. Cody, come on. So there's a point right there. So what do you think is the appropriate model? Remember, when you look at the data, there's one of the points which is right on the axis. You got it in there?
I did this.
First, second, stat plot. Make sure you've turned on. What are you doing? I said second stat plot. Okay? You didn't even turn it on yet. You're just sitting back there not doing what I'm asking. Enter to turn it on. Now go zoom 9. Zoom 9 button. There you go. Look at the shape. Yeah. What did yours look like? Those are not the points. Okay. Just clear that one. Delete. Go over there. Delete. Okay. Yeah. Okay. So second stat plot, right? 1. Just hit 1. 1. Okay. Enter. Okay. Zoom 9. If you got the points in already. What's that? Second stat plot, right? What are you doing? Okay. Second stat plot. You have it turned off, right? Enter to turn it on. Okay. Too many of you right now, you hadn't even done what I asked on the last slide. Okay. If you need help, ask. But don't just sit there sitting on your hands and then expect that, I'm going to be Mr. Rogers about you. Okay, why does this not work? Sorry. You got to try. If you don't try, there's no hope, believe me. Okay. If you looked at this data, what did it look like? Did it look like a straight line? Okay. What did it look like? Which shape do you think it looked like? It looked like it was a quadratic. Let me see if I got that on the side. It should have looked like this. There's one, there's one, there's one, there's one. Okay. If you didn't get that yet, let's do it. Put it in. Get that screen so I can come around and see that you at least got that. Yeah. Okay, those are not the points, are they? Stat edit. Yeah. What's that? Did you put the data in? Okay. Did you turn on the plotting of points? No. You're sitting on your hands over here. Turn on the plotting of points. Second, stat plot. Second, y equals for stat plot, and you make sure that it's on. And then you do zoom 9. Zoom 9 button. Okay? You get it? Did you get it? That looks right. Did you get it? Okay. I mean, if you figured out what that's good. If you figured out like what is the shape of the data, then you can go ahead and model it. And you did. And you got it right? So what is the one that that it looks like? Is it a linear, quadratic, cubic, or quartic? It's quadratic, right? Those points look like they could probably be approximated with a parabola, right? So then you would go to, in your calculator, you would go stat, calc, and that's a quadratic, so you hit 5, right? And when you did that, you should have got that screen right there. The quadratic regression equation is, and now it's got 3 terms, so it's got A, B, and C, and you're supposed to plug in for A, B, and C. So there is the regression equation. Okay. Now this problem actually was taken from a word problem in the book. Okay. And the problem said, a man throws a ball off the top of a building and records the height of the ball at different times, as shown in the table. Okay, that table is the data that we just plotted, right? Okay, find the quadratic model for the data. We already did it. The second part is use the model to estimate the height of the ball at 2.5 seconds. Right? In this table right here, we don't have a 2.5. Right? We have 0, 1, 2, and 3. So how are you going to find 2.5? Plug in 2.5 for x. Right? If you want to know a value that's not in the data that you already have, then plug in that value for x once you've got your model. So this would be y equals negative 16 times 2.5 squared plus 33 times 2.5 plus 46. So go ahead and do that and see what you get. Let's go to the dean. Go to the dean. Right now. Okay, second quick. So negative 16 times 2.5 squared plus 33 times 2.5 plus 46. I'm getting 28.5. Right. It looks like it's 28.5. Right. Which 2.5, you know, is halfway in between the 2 and the 3. Is 28.5 halfway in between 1 and 48? Probably not exactly. I mean, if you added those two up, you get 49, and divide by 2, that would have been 24.5, not 28.5. Right? So that's why it's useful to use the model. It's not a straight line. It's actually curved because it's a quadratic. Right? So this would fall into the category on the SOLs of making a prediction. You know, once you've looked at the data, you picked the right model, you made the model, and now you made a prediction. It's really not a prediction. A prediction would be what happens after this. You know, what happens at 5 seconds? That's in the future from your data. So what happened to this ball at 5 seconds? Yeah. You didn't get that? Did you try to do the same thing? Okay, well then you did it wrong, did you? Negative 16, where's plus 1600 coming from? No, you did times 2.5, and then you squared that. It's times 2.5 squared, negative 16 times 2.5 squared. It's only squaring the 2.5, not 16 times 2.5. Now try. Now add the next two terms. This squared, right, is only squaring 2.5. It's not squaring the negative 16. Okay, try this one. Look at the data, put it in, look at it, choose the appropriate model. Remember? Stat edit enters it. You shouldn't have to turn on the plotting of points, right? You already turned it on. Just do zoom 9 to look at the data. And then pick the right shape. When you get your points plotted, I'd be interested to see what you got in front of you. That's right. Deshaun had exactly the right plot. That looks exactly right. So what shape does that resemble? Does it look like a parabola? It looks like a cubic, right? It doesn't have just one turn in it. How many turns in it does it have? Looks like 2, which makes it cubic. So if you get it and you've got that shape, now that looks like you might have missed a point. Do you have the 4-2 in there? Stat edit. You don't have 4-2 in there. You could put it at the bottom of the list. 4-2. You didn't write one down. Does it look cubic? So go ahead and do stat, calc, and then pick the cubic out of the list. Enter. Boom, 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 boom. There you go. And you get something with a lot of decimals in there. You didn't do a zoom 9. Zoom 9. You got the right points. So what is the shape? 2 turns means cubic. How are we doing? Calculate. That looks right. Did you put in the data? Stat. Edit. -1, 1, 0, 2. You don't have the data there, right? You got like 0, 0. That's not one of our points. That looks good. Go ahead and make your model then. If you, yeah. No, but now you got to do the stat, calc, and then pick the right function. Right? When you did this, it should have looked like that, right? That's what it should have looked like if you put it in all correctly. And then again, you're comparing it to these shapes right here. Which one of these shapes does it look most like? You know, it's going here, it turns once, it turns twice, and goes up. That looks like cubic. So in the calculator, you go stat, calc, and cubic is the 6th option. And when you did that, you should have gotten a mess that looks like that. Right? A whole lot of decimals. Most that I saw, you know, were at least starting out with the 0.049. So that tells me you probably did everything right if you got to that point. Yeah. No. So again, you're not done until you've taken that y equals ax to the 3rd, etc., and then plugged in for the a, b, c, and d. There's your model. We're good with that? Sophia? Okay. Hunter? So that's, again, I wanted to give you some hands-on experience looking at scatter plots, picking appropriate models to use. We did one prediction. We should probably do some more. We'll probably do a little bit of this. We only have 4 lessons, right? So you'll see this again. We recognize the graphs of the polynomial parent functions, meaning the linear, quadratic, cubic, quartic. Investigate the scatter plots to determine if patterns exist. Like we just did, we saw a cubic pattern, right? Find the equation for the curve of best fit. We did that, right? Make predictions when we found the height of the ball at 2.5 seconds. And then, given a set of data, determine the model that would best describe the data, kind of a repeat of this stuff up here. But those are the things that we're supposed to know how to do. Although we won't know for a while the exponential and the logarithmic, but in the end, I mean, it's really just enter the data, pick the function. It'd be a new shape to recognize. That's about it. So this homework is just about the put in standard form, classify by degree, and number of terms. Easy. With 25 minutes to go, you can be done.